So what we have just figured out is if we go back to here, we figured out why the current is the same in the series circuit and why the sum of the voltages is the total voltage. And we've also figured out why it's the voltage is the same in the parallel circuit and it's the sum of the currents in the parallel circuit. So the only thing left is to explain what about this resistance thing. So why is in the series circuit the total resistance equal to the sum of the resistors? And why is it in parallel you take 1 over the total resistance? Okay, so now let's go back to this one here. So in the series circuit, we're going to take one resistor. Okay, now this resistor has a resistance, depends on what the resistor is made of, depends on the length of the resistor, and it depends on the area of the resistor. Okay, now let's take this one big resistor and chop it up into 2 smaller resistors. What did we do? We changed the L. We didn't change the C because it's still made of the same material. We didn't change the A because it's still the same area, cross-sectional area of the wire. All we did is we chopped it up into 2 pieces. And so if we were to substitute, instead of the letter L into this formula, L1 plus L2, and then separate it, so we can do that according to algebra, we get CL1 over A plus CL2 over A, but that's R1 plus R2. So that's where that formula comes from. Now what about the parallel circuit? Now this is where it gets real kind of cool. Okay, first we're going to take this formula and flip it upside down so that this is 1 over R equals A over CL. Sorry about all that noise. Okay, so I took this formula and I flip it upside down. So I've got 1 over R, A over CL. Now I'm going to take my original resistor and cut it in half, but this time instead of cutting it this way, I'm going to cut it this way. So I'm going to cut the resistor into 2 pieces. So notice this time the L didn't change. It's still the same length that it was before, but what has happened? I changed the A because each of the 2 pieces has a smaller area than it does before. And then we're going to use the same procedure that instead of the letter A, we'll have A1 plus A2. And then we'll break it apart into 2 pieces, and then that turns out to be 1 over R1 plus 1 over R2. So that's where those 2 equations are coming from. Pretty cool. All right, so if you want to do this, go ahead. You might need to blow up the picture so that you can see it better, but this is some examples of Ohm's law and what we've just been working on. So here's another one that you can work on, and here's a third one that you can work on if you want. So let's take a break, and when we come back, we will do the lesson quiz.